to services. No, I know this is a conversation that it's really triggering. It brings out a lot of strong emotions with developers. So I'll try to keep it down. Try not to shout. I know you'll get the urge. So I'm not talking strictly about stopping building microservices. This is not my goal to convince you that microservices are evil or that they're the devil. But I do want to show you about the correct way to build your project and basically to adapt the architecture to your needs. So, to introduce myself, I'm Itai. I'm an engineering manager at Fowler. Feel free to copy my details if you like. So, probably many of you here in the audience are wondering why you should stop building microservices. Most of you are saying, yeah, we use microservices in our company. They were great. Why are you talking about stopping building microservices? What's so wrong with microservices? Well, you don't really need to stop building microservices, okay? But you need to think about your architecture. Not every architecture is good for your use case. Let me demonstrate it by an actual conversation that I had with a young CTO of a young startup. So I met him, and he said, "Yeah, I'm building a new startup. I'm the CTO." I said, "Yeah, that's great, and we're using microservices." I said, "Okay, but why?" And he responded by, "It's the best way." I said, "Okay, yeah, but why?" He said, "It's it's the modern way to write software these days." And then I said, "Okay, but why is it applicable to your case?" He said, "No, that it's just the best way." And I told him, "Okay, you're a young startup. You have one developer. You have few to no customers. You have almost no traffic. Why on earth would you start with microservices?" And I see that a lot. Talk with people and say, "Yeah, we're building our system with microservices. Of course, that's how you're supposed to build systems." So that brings the question, what's wrong with microservices? So there are a couple of really, let's say nice things about microservices. First of all, microservices increase the complexity of your system. Okay, you have a much higher level of complexity in terms of development, deployment, maintenance. You need to manage the networking between microservices. You need to manage the deployments of multiple microservices. You need to understand how to deploy microservices, how they interact with each other. What happens if one of them crashes? How will it affect other microservices? The level of complexity increases dramatically. And of course, it makes your system a bit more fragile. The operational overhead increases exponentially because you need to have a Docker file for each microservices. You need to understand how it gets deployed. You need to monitor it. You need maybe distributed tracing to sort of track transactions through the whole network of microservices that now you have. It gets very tricky very quickly. You have challenges around data management, how to keep microservices from overwriting your databases. Maybe if one microservice wants to change its schema, how it will affect other microservices. So it also gets trickier. Testing gets way more complex because now every time you want to test a part of your service, you need to mock the other microservice. If you want to run an end-to-end test, then you need to spin up all your microservices and run the end-to-end test through all of them. So that's another complexity that starting to increase when you're using microservices. And of course, everyone that ever built microservices know that it can turn into local development hell. You're trying to build a new feature. You just add it to one microservices, and now you want to test it. But this microservice depends on other microservices. So you start spinning up all these microservices on your local environment. Sometimes it's even too big for your local machine to support, and it gets very tricky very fast. And you have the whole dependency management issue. Okay, so different microservices are dependent on each other. If you change some things at the microservice, you're not sure how it will affect other microservices, and so you need to test the whole system. And we go back to the local development hell when you need to spin up tens, dozens, or maybe even hundreds of microservices just to test a simple feature that you added. So I think now you're maybe even slightly convinced that microservices can be a problem, that they can be an issue. But then again, you see all these companies and they all use microservices. So how can that be? Why are companies using microservices at all? Why are not all of our companies building monoliths everywhere? So short answer is, as Thanos once said, there's just too many people. Okay, as companies grow, if everyone is using the same service, they get tangled in each other's feet. Now you have 100 people. If they all try to write on a single monolith, then you get serious issues about people stepping on each other's toes. And that makes microservices a much better option for larger companies at a larger scale. It allows teams to move faster. Okay, if each team is in charge of several microservices and they have well-defined interfaces with other microservices, then this team can build its own pipeline. It can deploy when it needs. If it will need versioning, of course. But then the team can move faster. It can move independently. You don't have to depend on other teams for every change. It reduces the blast radius. So now, if one team will make an error, maybe push some bad code, it will only affect that service. Okay, instead of bring the whole system down, it can bring only a small part of the system down, still keep the high uptime that you want for the entire system. Another thing that it can help is to reduce costs. Now you have something that requires a lot of CPU and something that requires very little CPU. You need something that requires high memory and other features that requires low memory. You can really work on optimizing your cost. This is, of course, only relevant when your system gets big enough, so cost will become an issue. It can also accept traffic better, increase the number of servers to match the increased traffic. So to sum up, so if you're using microservices, the complexity is very high. If you're using a monolith, it's lower. If you want more decoupling, that microservices can have near total complete decoupling of services, while monolith is usually highly coupled. And it's also very easy to extend microservice architecture. You need something new. Okay, you build another service and have it interact with the already existing services. With a monolith, can be tricky. So microservices are problematic when you start, but they seem to be a must as we grow. So how can we bridge that gap? Okay, what can we do to sort of win in both worlds? So the solution is build a decomposable monolith. And for that, I want to introduce you to a unique app that I built. I think it's really going to be strong. I think it has a lot of potential. I call it a to-do app, or the amazing to-do app. You can see the architecture. It's pretty easy to understand. You have a to-do module and the users module. The to-dos will allow you to add to-dos, check off to-dos, delete to-dos, list the to-dos. And of course, you don't want to see the to-dos of all your users. That's why you have a users model, which allows you to log in, log out, register, etc. Everyone knows what a users model does. So how did I build it? So it will be decomposable. So you can see the structure of the application here. So we specifically, we have the apps directory and the packages directory. So let's first look at the apps directory. Very simple, we have a single app, okay? The app is called to-do, has an index and a Docker file. If we look at the index file, see it's not very big. And the main thing here is by the way, I'm using Fastify, so sorry for all you Express people. So what you can see is that I'm calling two functions that get called from the users and the to-dos packages. And the one thing that these functions does is register the routes. So not very interesting so far, but let's look at the packages. So as you can see, the packages have a very specific structure. It has a logic directory, which holds all the business logic. It has the model, which holds the model. I won't go into these directories. They're not very important. I think you can imagine it in your heads. But what's interesting here is the routes and the SDK files. So we'll look at one of the packages, the users package. So how does the user package looks like? How does the routes JS file in the users package look like? It basically has one function, which is the register routes, which registers all the routes of this package. And as you can see, every route here just calls the logic. If we look at the SDK, it's very simple. It's very similar to the routes, okay? It's an SDK. No, it's not very visible with this lighting. It's an SDK, and also only calls the logic, and basically exports the logic as an interface. Okay, so now the amazing to-do app really exploded. So we have a lot of people. Everyone wants to use such a magnificent to-do app, and we had to increase our team. We had to increase the number of our servers. So what are we going to do? Luckily, we built the monolith as a decomposable monolith. So we're going to extract the users to a new app, okay, or basically a new microservice. It also has a Docker file and an index.js. If we look at the index.js, you see that it's very similar, except now it doesn't call both register route functions. It calls just the users register routes. And we will also change the SDK. So the SDK now is not just exporting the interface. Now what it does is it calls the routes of the user's app. So this way, we don't need to change anything in other services that are calling this service. It basically works seamlessly, and in a couple of minutes, we separated the user's package into a new microservice. So what did we get? We have low communication overhead, we have low operational overhead, and we have the modularity and the flexibility that microservices give us. And to summarize, if you look at the one added column here, so with a decomposable monolith, you get some complexity, okay? You can't do whatever you want as you do with a monolith. But you get high decoupling. Okay, the system is way more modular than a single monolith. And it's way more easy to extend it. So we get the easy extensibility, high decoupling, and just a little bit added complexity. So it wins. So thanks, everyone. You can see the project in my GitHub page. Thank you. Any questions?